Yes, good morning, everyone. Hello again from Reading. I hope you had a nice icebreaker event yesterday at the end of the day and got to interact a little bit more yourselves. So indeed, this morning we have, excuse me, still struggling with my voice a little bit. This morning we talk about emissions. Before the coffee break, we also have more about evaluation and quality control, but let's start with emissions first. We all know that emissions are the key driver of atmospheric composition. This is the beautiful animation that was made now a little bit, a while ago, but exactly showing the point that without emissions, we don't have air pollution in most cases. Of course, there are natural emissions as well for the various species, but emissions are key to understanding atmospheric composition and understanding air quality at the surface. So yeah, during the COVID times, with the emissions being reduced, we saw a clear impact, at least in these model simulations, but also from observations on air quality around Europe. So this was key also to our proposal, as I indicated yesterday already, for the second phase of CAMS that we are now running, to add more work on emissions, both for air quality and for greenhouse gases. And the whole idea being do what we already do well with the bottom-up emissions, more temporal and spatial structure, fire emissions already that we have, fluxes of greenhouse gases, but step it up significantly to use more observations to look at air quality and greenhouse gas emissions closer to real time. We can better monitor the emissions. And especially COVID showed us clearly that it's really difficult to deal with a situation like that if we don't bring in more information than we normally use. So when we look at the contribution agreement again that we signed with the Commission, the different elements of the service portfolio, I highlighted here the two main parts under the CAMS 2 5000, the CAMS 2 6000. This is where all the contract numbers come from. We have both production baselines, so continue what we're doing, and 5000 is focused on the greenhouse gases, 6000 is focused on the air quality, and then also have new service evolution. So again, we continue what we have been doing. We even increased that a little bit. We could bring in more funding, especially through the ECMWF development, but then on top of that, further develop. When I talk about bringing in more observations, I chose not to show the normal diagram I showed yesterday about the C2MVS, but this is another one that shows more the complexity, in this case of the full carbon cycle, but you can argue the same thing for some of the air quality species as well. If we want to look at, for instance, fossil fuel emissions, we really need to understand all the elements that dominate the atmospheric concentration. So this brings in a whole range of observations that we can use to better constrain what we are doing. We have to constrain the ocean, we have to constrain the terrestrial biosphere, we have to constrain the atmosphere, and we can also look at for instance, fossil fuel proxies through population density from night lights, location size of power plants. And if we look at the terrestrial biosphere, we can constrain vegetation with different observations. So there's a whole range of observations we can use as part of this really step up to bring in more observations to look at emissions in general. So today, most of the presentations will focus, as expected, on what we are currently doing. So there will be presentations from Hugo, from Claire, from Frederic, talking about the different things that are ongoing on regional emissions, global emissions, both fossil and to some extent natural, the atmospheric inversions for greenhouse gases. Then there's some other activities as well that I will briefly go through in the remainder of my presentation. GFAS, the Global Fire Assimilation System, and also what we are trying to do in terms of using activity data. There will be the report from session 4 later this morning, We won't really touch on the ECMWF and the observation-based air quality emissions the remainder of today, but there will be, as I said, more talks about the evaluation quality control. And I highlighted it here because we already have this in place for most of the current services, but we also need to think and implement this for the new elements that we are providing in the near future. So talking a little bit about GFAS, I won't spend a whole lot of time because I don't have that time, but we have been running GFAS for quite a while now. It was developed early on as part of the GEMS and MEC projects and has been running operationally for a long time now. And we can make these beautiful animations like the one you see here for last year, where these fire emissions take place. This is the daily fire radius power in watts per square meter, and you can really see the main contributions from the tropics, but then also all the different wildfires in the higher latitudes. So always really insightful, and this is at the basis of then our atmospheric forecast of the different pollutions. So GFAS is among the most visible CHEMS products in the media. We use it a lot to communicate. Fires to attract attention from the general public as well. There's an example here on the right from the European State of the Climate that the Climate Change Service provides every year. This is the carbon emissions for the European domain. I think I can't actually see it because there's something blocking the figure in my screen, but it shows you the dominance of wildfires, especially in August compared to the long-term mean, while the rest of the year was actually less than normal. So these are really insightful figures that we use to communicate. So GFAS has been able to provide a stable service provision, but we still face several challenges. MODIS data that have been at the core of GFAS are no longer guaranteed. We see more and more small issues with the instruments, some outages that we need to take into account, but also there's a threat of ending the funding of not just MODIS, but the EOS constellation in general. So we really need to watch this to make sure we don't have a problem at some point without instruments. So what we've been doing is introduce other and new instruments, but this requires careful monitoring and bias correction. The FRP estimates from the different satellites are all slightly different because of different detection limits, different orbits, etc. So this really needs to be done carefully to have a consistent GFAS product. We've also been working together with the contractors on the Plumerise model, especially in the hourly GFAS suite, to implement this. This has not been straightforward, but we've now been making good progress recently, so hopefully this can be implemented operationally soon as well. The transition from the daily suite, we provided daily GFAS estimates to the hourly suite. This has already been picked up by the regional models, but for the global services, we still have some issues to solve. And especially, for instance, for the global reanalysis, which spans a long time period, we have to be careful we don't introduce sudden changes. So this, again, is something we need to do carefully. We cannot just go from one to the other. And this links to the next bullet point. It's really important to ensure we have a consistent data record, not just for the use in the reanalysis, but in generally, if we want to make plots like the one on the right, we need to make sure our climatology is sound and that we compare apples with apples. So these are all things that need to be considered in this busy period where we are transitioning into new operational suites for GFAS, and this goes along also with the transition to the new supercomputer in Bologna. So a lot of things to solve, but hopefully we get it all sorted on time. And then also we had a bit of a gap in our GFAS development support. This was mainly because of Brexit reasons. We were not entirely sure how to deal with this and needed to rely on advice from the Commission. Now we're actually close to having a new contract to help us with further development of GFAS, supported by KCL and their subcontractors. So that's now getting in good shape. A little bit on activity data. So this is something new, but I think we've mentioned this before. So we are negotiating a short-term contract with Carbon Monitor to benefit from its expertise in using activity data to estimate CO2 emissions. So these are recent developments in the science community, especially how can we use activity data, more data that's closer to real time, to look at emissions. And especially this was very relevant during the COVID period. I'll show a next figure in the next slide, where we also looked at air quality pollutants. But for CO2, Carbon Monitor has been really leading this effort, and we're happy to now start negotiating a contract with them to really benefit from their expertise and see how we actually can use this data, not just for showing the change in emissions, but hopefully also how we can use this data in our models. And as I said, we have been doing this also for air pollutants, and this is another figure produced by BSC, where we looked at the COVID period and tried to account for the changes in emissions during that period using other data than we normally would use to provide the base inventories. So the plan is to really bring together these efforts. We are drafting new ITTs where we will have an increased focus on generating emissions based on real-time activity data and emission modeling. So this is very important, not just as products on their own, but also really to include in our modeling systems. And this again needs careful attention. And I missed the discussions yesterday, so I hope this was being discussed as well. But otherwise, this discussion will be picked up. How do we make best use of this data in our modeling systems? So my final slide, we are already doing a lot on emissions. These are highly valued products in all aspects, but we want to do a lot more. And we actually have a very tight schedule for development, testing, and implementation. On the one hand, we have the CO2 that should be operational in 2026, making use of the launch of CO2M, but also air quality emissions, where we actually have an even tighter deadline, tighter aim to be operational by 2025, making use of Sentinel-5P, Sentinel-4, and Sentinel-5. So this ramping up phase is critical. We need to work hard, we need to test thoroughly, and hopefully implement a good new service. And as Hugo said yesterday, no pressure. Thank you for your attention.